So let's actually discuss about this question. Okay, they mentioned about ethanol. Okay, they are going to dimerize in alkaline solution according to the following equation. Initial rates are measured, okay, with different concentrations, and we need to actually find out deduce the order of the reaction with respect to ethanol. Okay. So let's actually deduce. Okay, Charlton, what is
Second order.
louder, Charlton?
Second order.
Okay, why second order? Can you actually explain to us?
Uh,
When this is double, this is constant.
that also double.
Yeah, this is
That one also
also
double.
double. Okay, so this is going to be first order reaction. Okay, first order reaction. Now deduce the order of the reaction with respect of OH minus. Now OH minus. So if you want to, because we have determined it's going to be first order. Okay, so let's actually erase this part. Okay, let's see how we are going to compare. So if you see here, okay, 0.15, there is no way to change the aldehyde to become constant. Okay, so here this is double. Okay, this is also double. Okay, so we know, okay, when you change from 2 to this, when this is double, because it's first order, this is also going to be double. Okay, if I times that, I supposed to get 4. Okay, I supposed to get 4, but there is also another times 2 which going to make it into 8, because this is 8. So this is also going to be, it's just indicating that this one belongs for the aldehyde. This one, when you times by 2, this is going to be times by 2 again. So Lavi, what can you say about the order of the reaction of OH?
It's
Can you see the part that last time we actually learned? Like for example, okay, when this one is involving both of them. Okay, and then I know that aldehyde is first order. Yeah, so when the aldehyde is first order, when this is double, okay, of course this one is going to be double. Okay, it means 2 times 2. I supposed to get 4 only. Yeah, the remaining that I times, okay, must be referring to the OH minus. So if this one is times by 2 double, what happened was this one is also times by 2. Why? Because earlier I do not know what is this value, but in order to make it 8, I must times another 2. 2 times 2 times 2. So it means this is going to be, when this is double, this is also double. Okay, so that is going to be first order also. Can you understand, Lavi?
yes, sir.
Yeah. Jason, can you understand this? Okay. Now you have found out, okay, about the order of the reactions. Okay, so state the overall rate equation for this reaction. So they say rate. Okay, I do not know what is K, so just put K, and then state the overall rate equation. Yeah, so just put bracket CH3 CHO. No need to put 1. Okay, just leave it as it is, and then this is going to be OH minus. Okay, both of them. Okay, 1 and 1. Okay, state the units for the rate constant. Okay, if you want to state the units for rate constant, rate is mole per dm cube per second equals to K. This is going to be mole per dm cube to the power of 2, because 1 and 1. Yep. So to the power of 2. So K is going to be mole dm negative 3 per second divided by mole dm negative 3 to the power of 2. Cancel. cancel 1. So you will get m mole negative 1 dm3 per second. Calculate the initial rate of the reaction. Okay, relative value for the reaction where, okay, the CH3CHO is 0.3 and then OH minus is 0.03. Okay, so they say relative value, okay, using these values. Okay, so here, okay, what I can do is there a need to actually change find the K, Justin? Do we find the K for this? It's only 1 mark.
No need.
No need. Okay, no need to find the value of K. We just deduce. Okay, let's say I use this one. Okay, 0.1. When it becomes 0.3, okay, it means that this one is times by 3. It means 1 must also times by 3. Okay, first order. Okay, and then when I look at OH minus is from 0.15 to become 0.03. It means I times by 2. Okay, I times by 3, times by 2. So if you times by 3, this is going to be times by 3. If you times by 2, this is also going to be times by 2. First order. Yeah. So here the answer will be 1 times 3 times 2, which is going to be, the answer will be 6. That's going to be initial rate of reaction using relative value. There's no unit, I'll just put 6 is enough. Now, a 3-step mechanism, okay, like before that, I'll just write down the rate equals to K, the CH3CHO, and then OH minus, okay, I put it over here. Now, a 3-step mechanism has been proposed for reaction A. Step 1, step 2, step 3. So it means there is a slow step and fast step. There will be, the slowest step will be the rate determining step. Okay, using your answer in equation 3, predict which one is the rate determining step. Yeah. So Arnetta, can you predict which one is the rate determining step? 1, 2, or 3?
First.
Yes. Step 1. Can you tell me why you selected the first one, Arnetta?
Because all of the reactant, all of the reactant is there.
Yes. In order to actually determine the slowest step or the rate determining step, you need to look at the rate equation. So the aldehyde is there, the OH minus is also there, and then all of them are to the power of 1. Okay, so this is going to be the one that I'm going to use to determine my rate determining step. Okay, so step 1, okay, is going to be my rate determining step. So your explanation will be step 1 has both CH3, CHO, and OH minus. Okay, and it's the slowest step. Okay, you can just write it down, but I think the answer will be, okay, it contains both CH3, CHO, and OH minus.